Well, dear students, good morning. Today in this video, I am going to solve some good questions of chapter Kinetic Theory of Gases. So please see. Actually, in this question, there are many problems which create confusion, and we people avoid this chapter. No, this is simple chapter, please. Much simpler than the mechanics part, work, power, energy, neutral of motion. So please take care and ask your friend to learn it properly, because selection in IT and NIT depends on a small margin. If you by mistake lose 1 mark, then you are behind thousands of people. So be careful and have a precise study of the topics. Don't run behind the luck. So here question is equation of a state corresponding to 8 gram of oxygen is. But you know, equation of gas generally we write PV equal to nRT. Here N represent number of moles and 32 gram of O2 is 1 mole. So 8 gram equal to 8 upon 32 1 by 4. So simple question just for revising. So D part is correct. This is simple question here, but important also. Actually, I have told you earlier also that people are very much afraid of more concept. I have told you many times, or who are just new in this chapter, 1 gram molecular mass of compound. I am repeating here, 1 gram molecular mass of compound is equal to molecular mass taken in grams. यही बात समझ में आती वाट इज मीन. फॉर एग्जाम्पल ऑक्सीजन, 1 ग्राम मोलिकुलर मास ऑफ ऑक्सीजन इक्वल टू 32 ग्राम, and 1 gram molecular mass is 1 mole, and also 1 gram molecular mass is 1 mole. For element, 1 gram atomic mass. For element, 1 gram atom mass of element is equal to atom mass taken in gram. For example, calcium, 40 gram of calcium is equal to 1 gram atom mass of calcium, and is equal to 1 mole of the calcium, and 1 mole of element has atoms equal to Avogadro number. 1 mole of compound has molecules equal to Avogadro number. So please be careful. Yesterday many students were telling me other way, and actually I am very sorry to say that even authors write collection of 6.03 10 to the power 23 entity is 1 mole. This is bakwas, total rubbish. I don't like it. You talk in terms of atoms or molecules. In 1 mole of every element there are 6.02 10 to the power 23 atoms, but we can't count the atoms. Therefore we have to learn that 1 gram atom mass of element is 1 mole, and 1 gram atom mass element, mass of atom taken in grams. Just I told you the example. Now here there is another question. Average translation energy. Average translation energy and root mean square velocity, RMS velocity of oxygen molecule are respectively the energy 6.21 10 to the power minus 21 joule and 484 meter per second at 300 Kelvin. The two at 600 Kelvin are, there are options, so we have to find answer only. I will make the average translation energy. So confusion start rising. Actually, the book I have with me, I have learned whole physics, but there is something wrong here regarding this. Total energy per molecule of any gas, total energy possessed by at any temperature is F by 2 kBT. Please learn this. It is total energy. Kind energy. That kind energy, sum of translation and rotation. But here it is only translation, means it can move along x-axis, y-axis to 3 degrees of freedom. So 3 by 2 kT. So kind energy proportional to of translation, proportional to whether it is total or translation, proportional to T. So K2 upon K1 is equal to T2 upon T1. So K2 is equal to K1 is 6.21 into 10 to the power minus 21 into 600 upon 300. So it is 2, 4, 12. So this answer is there. And velocity also C bar proportional to under root T. So C1, C2 bar upon C1 bar. I write C bar, C. So it is under root 600 upon 300. So C2 bar is equal to C1, 484 into root 2. Root 2 here is 1.41 and if we multiply we get 684. It is 684 meter per second. So these are the two answers correct here. There are many options, so please be careful. Now next question. Again on same pattern, the molecule of given mass of gas, the molecules of given mass of gas have RMS velocity 200 C bar at at 27 degrees centigrade and 1.1 0 10 to power 5 Newton per meter square is equal to 200 meter per second. Then what will be the value? What will be C bar? What will be C bar at 127 degree centigrade and 0.05 10 to the power 5 Newton per meter square. So here he has involved two things, the pressure as well as temperature. So learner start thinking totally different way, okay, how to relate these two. Just now I told you the C bar proportional to under root T. Why I am not taking this one here? Actually here C bar in fact 3P upon rho भी होता है. P is the pressure, rho is the density. So if you are asked in terms, if you are given question in terms of density, then you may think about this. But here density is not given. And this derivation C bar equal to 3 RT by M has been derived from this. So pressure has no criteria in this equation. For given gas M same रहेगा R same तो that equal to T. So therefore C1 bar upon C2 bar, sorry I should write like this. तो जो unknown है उसको न्यूमरेटर बना लिए अंडर रूट 600 upon 200. So it is C bar C2 bar equal to C1 is 200. It is उल्टा हो गया 200 sorry मैं दूसरा क्वेश्चन ले लिया. Temperatures are under root T2 upon T1. So it is 200 under root. Temperature here 127 degree centigrade. 127 plus 273. Temperature in Kelvin upon it is 27 plus 273. So it is 200 under root. How much is this? 400 upon 300. Cancel. So it is 400 upon root 3 meter per second. So don't think there are two things here. So these two things here together creates little tension among the learners. Velocity proportional to root mean square, speed proportional to square root of absolute temperature. Depend upon pressure. If you are given question in terms of density also, then you can think. Yes. Here again, actually, this last question has been asked in NEET 2016. Now, next question which has been asked in JEE Advanced 2013. Two non-reacting monochromatic ideal gases have their atomic masses. Two non-interacting monoatomic. Which gas called monoatomic? Whose molecule has one atom. That is why you are given atomic masses. So 2 and 3. M1 upon M2. 2:3. And their pressure, the ratio of the partial pressure P1 upon P2 is equal to 4/3. 4/3. I have told you Dalton law of partial pressure. Actually, many things here are not mentioned in syllabus. Actually, they are taught somewhere else and asked here. So you are asked here okay, the ratio of their density. The ratio of their density is 1:4, 1:2, 6:9, 8:9. Two known reacting monoatomic ideal gases have their atomic masses in ratio 2:3. The ratio of their partial pressure when enclosed in vessel kept at constant temperature. Yes, ये together. The two gases are kept at constant temperature and closed in a vessel. What the ratio of their density? So pressure of gas, you know, P is equal to 1/3 m n upon v into c स्क्वायर बार भी है और P इंटू V इज इक्वल टू एन आर टी भी लिखते हैं हम. व्हाट इज एन? तो ये सिलेक्शन करना मुश्किल होता है, क्या करेंगे. You are given ratio of atomic mass and you are asked density. तो डेंसिटी जो रो है वो मास अपॉन वॉल्यूम होता है. Mass upon volume. So we have to think, not this. Here PV is equal to N equal to molecular mass upon molecular mass RT. Or P into V upon M is equal to RT by M. V upon M, P upon rho, yeah. RT by M. So you are given ratio of molecular mass, you are given ratio of pressure. So you are asked ratio of density. So you can write P equal to rho RT upon M. So P1 is equal to rho 1 upon M1 RT. The two gases are at same temperature in the same container. Or P2 is equal to rho 2 upon M2 into RT. So P1 upon P2 is equal to rho 1 upon rho 2 or into M2 upon M1. Or rho 1 upon rho 2 is equal to P1 upon P2 into M1 upon M2. So thing becomes simple. P1 upon P2 4/3, M1 upon M 2/3, so it is 8/9. Only practice of problems can make you confident. Just don't think that I assume that you may know all these things, but I may be revising the topic. You can take this way also. Don't think that I know everything. I have to revise again and again. So this was one question here. Now a mixture of 2 mole of helium gas, atomic mass 4 amu, and 1 mole of argon gas, atomic mass 40, is kept at 300 Kelvin in container. The ratio of their root mean square speed. What is the question here? Two mole of helium gas and 1 mole of argon gas, we are given atomic mass 2 and 4, are kept at 300 Kelvin container. The ratio of their root mean square speed. Again the same thing, C bar equal to under root 3RT upon M. The two gases are at same temperature at 300 Kelvin. So what is the ratio of their? So C bar of helium under root 3RT upon 4. C bar of argon under root 3RT upon 40. So C bar He upon C bar argon is equal to 40 upon 4. It is root 10. And remember root 10 is 3.16. 3 point, कुछ बातें याद रखें आप. Root 10, 3.16. And here I am telling here unnecessarily 1 year. How many seconds? 3.16, 10 to the power 7 seconds. You know, I have learned it. It is root 10, 6 plus 1, 7. If you multiply, you will get this. So I have solved these questions here for you. More questions are there. I will be telling you later on in next video. But please, this chapter is very simple. Have a good practice. If you want to get selected for an NEET or any exam of engineering test, so you have to learn. Actually, I have got chance of checking the PMT test conducted by CBSE, and I found last chapter like wave, like atomic physics, radioactivity, semiconductor was not attempted by students. It means they have not completed the syllabus. So please be in hurry and complete syllabus and revise it again and again. Thank you.